This device is designed to give a demonstration of water hammer or surge, which can happen when valves in the system are rapidly closed. We have about 200 feet of half-inch copper coil with a valve on the discharge and a valve on the inlet side of the coil, and a surge suppressor at the discharge point and a surge suppressor at the inlet point of the coil. When liquid is moving rapidly through a pipe or a system and it is decelerated quickly, energy gets concentrated and can cause a pressure spike, which can be 4 to 8 times the normal flowing pressure. So we'll demonstrate this by using garden hose and tap water and allowing water to flow through this coil and then out through an exhaust hose. Now, everything is normal, pressure is low because everything is flowing nicely. When I close this valve quickly, you will see nothing for a split second because the liquid will continue to travel through the coil, but there will be no liquid at the top. The liquid will actually reverse itself and come back up and hit the valve, and you'll see a pressure spike. We have gauges that are called telltale gauges. So they have 2 needles, and one needle will stay up at the highest pressure point generated when the valve is closed. Now, at this point, the pulsation dampeners are isolated from the coil, so there will be no cushioning effect from the suppressors. All right, so now I'm going to close the valve rapidly. And you can see the shock that occurred, slightly delayed as the liquid traveled and then reversed back up to the valve. Now, we hit 400 psi peak pressure from a 0 pressure point in an instant so quickly that you could not capture it with the human eye, but we're able to capture it with the gauge. Now, I'm going to demonstrate this again. I'll reset the telltale needle back to 0, but this time I'm going to introduce the surge suppressor into the system. I'll open the valve and allow the water to flow through this coil like I did before. But now watch the coil and you'll be able to observe on the telltale needle that there's virtually no movement. No 400 psi pressurized, no possible damage done to the piping system, or if a break were to occur, no spill or possible damage to any employees nearby. It's that amazing that this is the vessel that allows that liquid to return, but instead of slamming into the valve, it gets directed up into this gas-charged surge suppressor, which allows the liquid to slowly decelerate or change velocity slowly so no pressure spike occurs. For this next demonstration, instead of having the valve close at the inlet to the coil, I'm going to close the valve at the discharge of the coil. And I've got a dampener installed there which will absorb the shock, but initially I've got the dampener or surge suppressor isolated. When this valve is closed, there will not be the delay because the water is not reversing itself. It's being rapidly stopped at the discharge. And again, I've got a telltale needle gauge that will be able to see the reaction. As you can see, the whole cart shakes instantly as we stop this flow. And the pressure spike went to 400 psi. Again, enough to break most pipes that are specially made out of PVC or plastic, do damages to gauges, flanges, fittings, and damage to pumps. Now, I'll open the valve and I'll reset the telltale gauge, but this time I'll introduce the surge suppressor into the system. And again, what the surge suppressor does is allow for this flowing liquid to go up into it, accumulate, and decelerate slowly so that no pressure spike occurs. So now watch the whole system as I close the valve. As you see, nothing happened. We protected the system, we protected the operator, the people, we preserved product, we made the EPA happy, all by this device that absorbs that shock and prevents a pressure spike that can be so damaging to the system.